Hi everyone, in this video we are going to cover section 8.2, interest, and learn all different types of things about interest and how it's calculated and how it will affect you as you go through your life. We start out the section with simple interest. Interest is, as a definition, the money that a person pays to another, borrower and lender, to use the lender's money. So the amount you deposit into a bank account is called the principal. So these are just the terms that you should be familiar with in this section and moving forward. And then the bank sets the interest rate for the account that you have depending on the type of account. The most basic formula for computing simple interest is I equals PRT. Again, P the principal, R is the interest rate, and T is the time in years. I equals PRT. And let's do an example using that formula where we deposit $500 into a bank account paying 6% interest, and we want to find out how much interest we'll earn if we let that $500 sit for 4 years using the simple interest formula. So let me write the formula down again. I equals PRT. So the interest is equal to the principal, that's the $500 that we deposited, times the rate, 6%, but I'm going to write that in decimal form, decimal point 0.06, times the time, which is 4 years, and that is equal to $120 over those 4 years that you will earn in interest. Now we use a slightly different formula to talk about what's called the future value. Using simple interest, the future value is just a formula for the amount that I'm going to have in the future. And the only difference is instead of the P and the RT in the simple interest formula, we also have in the future value formula this 1 plus. And all that 1 plus does is it kind of adds in the original principal. And so it's a way of using one formula, finding how much I will have in my account at some date in the future, after so many years. Okay, so A equals P times 1 plus RT is the future value formula for simple interest. So in this example, we're going to use that future value formula and find out what happens if we deposit $1,000 into an account at 3% interest for 6 years. Now, I don't just want the interest amount. I want to find the future value of this account. How much will I have in the future? So formula for this one, A equals P times 1 plus RT. A is the amount that I'm looking for in the future. P is my principal investment, $1,000. 1 plus the rate, 0.03 is 3%, times the time is 6 years. And if you type all of that into your calculator, you should get $1,180. Now, if I just did I equals PRT for this problem, I would get $180. Oops, $180. And then I could add that back on to the original amount to get the 1180 that I just got over there. But the future value formula here just gets it all done in one step. Now we'll talk a little bit about compound interest. As a definition, compound interest is interest that is paid on the principal plus the previously earned interest. So every month, if you get an interest added onto your bank account, into your savings account, you make a little bit more the next month because that interest compounds. You get a little bit more because you have a little bit more. If the interest is added yearly, we say that interest is compounded annually. So that's just when they add on the interest, the bank or whoever is adding the interest on. Or if they do it every 3 months, that is 4 times per year, we say the interest is compounded quarterly, or we could compound interest monthly, and that would be 12 times per year. Now, in this example, we show how you can compute compound interest the long way. All right, so we've got 3 years that where we want to replace a sailboat with a larger one in 3 years. We're saving up for a down payment. We deposit $2,000 into a bank account that earns a ton of interest. 10% is a ton of interest, and it's compounded annually, which means each year they add on the interest, and then the next year they add on the interest, and then the next year they add on the interest. And so using our future value formula, we get that 1.10, that's 1 plus 10%, times $2,000 gives me this much money. And then the next year, that $2,200 times 1.10 gives me this much money. And then the next year, 2420 times the 1.10 gives me this much money. So I have in my bank account $2,662 after 3 years. Each year I earn a little bit more because I have a little bit more in my bank account. And now this graphic is the same for the previous example. It just shows it a little bit more visually. So you can take a look at this, pause the video if you want to. But that 2,000 times 1.10, we're showing that each year we multiply by 1.10. So that's kind of this exponent. So instead of multiplying by it twice, there's an exponent of 2 for 2 years. Multiplying 3 times, we get an exponent of 3 for 3 years. And we put it all together into what is called the compound interest formula. So if we have an account with a principal P, and it's paying an interest rate R, and is compounding M times per year. So that M, it could be once per year if it's annually. It could be 4 times per year if it's quarterly. It could be 12 times per year if it's monthly. So that's going to be something we have to look for in the problem. But if the money remains in the account for N time periods, then the future value A of the account is given by this formula right here. Okay, so that's our main, biggest formula of the section. Okay, and then it says, notice in the formula we have replaced R by R over M. So that's just something we've got to pay attention to. Okay, how this formula changed from the future value one. That is the annual rate divided by the number of compounding periods. And the T in the exponent is replaced by N, which is the total number of compounding periods. So we'll just take a little bit more time to set this one up carefully. Our first example using this formula is a little bit wordy. Go ahead and pause the video so you can read through it once before I kind of start talking about it. But there are lots of advertisements that we come across. I know Raymore and Flanagan, like the furniture stores, do this a lot, where you don't have to make any payments until the year 2022, or you don't have to make any payments for 2 years. There's all different ones. And in this example, we're looking at a home fitness center on sale for $3,500 and no money down, no payments due for 6 months. Okay, so that's kind of the setup. But the thing is that although you don't have to make any payments, the dealer is not loaning you money for 6 months for nothing. They are doing this for their advantage. You have borrowed $3,500. And in 6 months, the payments that you have to start making are based upon that fact. Assuming that your dealer is charging an annual interest rate of 12% compounded monthly, what interest will accumulate on your purchase over the next 6 months? Okay, so let me go back and highlight the important stuff here. 12% over the next 6 months. We're borrowing $3,500. So let's write down all of this important information. P, our principal, $3,500, the amount that we're borrowing. R, the interest rate, is 0.12, 12%. M is how often that interest is being compounded or calculated or added on. 12, because they say the really important word, let me underline it, I didn't underline it, monthly, compounded monthly, something you have to look for in the problem. And N, the number of time periods, in this case, is 6. So we can substitute that into our compound interest formula, 3,500 times 1 plus 0.12 over 12 raised to the 6th power. So you type all that into your calculator, and we find that the future value of this account is $3,715.33. So over those 6 months, I didn't make a single payment because they told me I didn't have to, and I now owe $3,715.33. So how much interest? How much interest has accumulated over those 6 months? Well, if we take that $3,715.33, subtract out the $3,500 that we borrowed, well, it cost me $215.33 in interest just to let that account sit and do nothing for 6 months. Okay, so that's something that is common. that you will run into if you buy furniture, sometimes if you buy electronics. Home gym is this example. I think even some car dealers do this. No payment for your first 2 payments or something like that. So it's important to realize that you are paying. You're just paying interest. In our next example, we're going to find out how much you need to deposit to have a certain amount by a certain time. So in this one, we want to have $60,000 at age 18 for our child. We put it in an account that pays 4.8% interest. And here's an important thing. Look for the compounding word, compounding quarterly. Okay, so if you didn't read through this problem yet, I've highlighted the important stuff. Pause the video, read through it once. All right, so our A in this one is, there we go, 60,000. P is the amount that we're looking for. How much do I need to invest? R, the interest rate, 0.048. M, the number of compounding periods, is 4 because it says quarterly. And finally, N, how many times is that interest going to be added onto my account? So if it's quarterly for 18 years, 4 times per year for 18 years, 4 times 18 is 72. So that's something that multiplication, you got to do that ahead of time to figure out how many times the interest is going to be added on for the duration of the loan or while the account is sitting, in place. All right, so let's substitute into our formula. 60,000 is equal to P times 1 plus 0.048 over 4 raised to the 72nd power. All right, so what I would suggest is typing everything over here into your calculator. $60,000 equals P times. Now in my calculator, I got 2.360461386. So that 1 plus in parentheses, you can do that as its own separate step in your calculator, or use parentheses around it and raise it to the 72nd power. Now, I'm keeping this whole big thing stored in my calculator because I need to divide 60,000 by that whole big number, 2.36. That got a little messy. So you can use in your calculator $60,000, 60,000 divided by second ANS, or type in that whole big long number. But we want to make sure that we don't have any, rounding errors. So if you rounded that to 2.36, you wouldn't get as precise of an answer. And in my calculator, I got 25418.75939. Okay, that's what my calculator gave me. But now I'm going to interpret that as a dollar amount. So we have $25,418.76. So we need to deposit over $25,400. Let that sit for 18 years. And then our 18-year-old child, or my 18-year-old child, has a $60,000 bank account that they can use towards school or something. That's a pretty big investment to just let sit there for 18 years. But that's what we end up with. Now, in problems where we're trying to solve for the time, the n, we're going to need to use logarithms, which we already did back in Chapter 7. And we could do here, and if you click on the help tools in my math lab, they might suggest that you do this, but we're going to do something different for these examples, and I'm going to have a follow-up video where I record myself using a spreadsheet. So in this, when you get to this homework section and the problems where you have to solve for the time, you will need to use a spreadsheet. And like I said, I'll have a video in Blackboard that I'll upload in a little bit that shows you how to use these spreadsheets, okay? So if you see this question on my math lab where you have to solve for the time, you can use logs, you can use the help tools, but I would highly suggest using the spreadsheet, and there will be a follow-up video soon. In this example, we're looking for Dee Dee's investment of $8,500 to double in value at a 6.5% interest rate per year. And we're going to answer this one using the spreadsheet, but I'll show you how to set it up here in this video. Okay, so we're trying to get our investment to double. 8,500, if you double that, that is 17,000 equals 8,500 times 1 plus my interest rate is 0.065 divided by 1 raised to the nth power. Okay, how did I know that it's divided by 1? They tell me per year. It doesn't say anything about compounding monthly or compounding quarterly. In this case, we are compounding annually or per year. So that's what the setup would look like. And if we solve this for the number of years, n in this case is approximately, we'll use the squiggly equal sign for approximately 11 years. How did I get that? Stay tuned for the next video where I show you how to use the spreadsheet. This is just a kind of cool add-on. We're not going to use this in any homework problems, but it's called the rule of 72, and it's how we estimate doubling time. For something to double in value, it's approximately 72 divided by the interest rate, the growth rate. Okay, and in the previous example, 72 divided by 6.5% is approximately 11. So it's kind of a cool feature if you ever wanted to figure out how long it would take your bank account to double. All you got to do is take 72 divided by the interest rate that your bank account is earning. All right, that is it for this video. Like I said earlier, stay tuned for the next video that will show you how to use the spreadsheet to answer some of the questions on the homework. Thank you for listening. Have a wonderful day.